Hello everybody. Welcome to the Skill 20 video lesson. Today we're going to talk about geometric series. So what is a geometric series? Well, it's a series made up of a geometric sequence. And we just talked about those in a previous lesson. So we're going to be thinking of things that have what is a common ratio. So that's going to be, hold on just a second. So that's going to be the first thing we fill in here, common ratio. All right, so some notation. We're going to use the formula S sub n. So S sub n is our notation for a series. So we're going to be finding the sum of n terms. So n is the number of terms to sum up. Our first term will be denoted by a sub 1. And our common ratio is R. So we need to know those things in order to use this formula. All right, so with that formula, let's find the sum of the first 7 terms of the geometric series defined by 0.4 plus 4 plus 40, blah, blah, blah. Okay, so the first thing we have to know is that 7 is our n because that's the number of terms we're summing up. 0.4 is our a1. To figure out our r, what we have to do is take a term that follows a previous term. So a couple ways we could do this. I'm going to take 40 and divide it by 4, which gives me 10. Okay? So we want to find S sub 7. So S7 is going to be equal to our first term, A1, which is 0.4, multiplied by 1 minus our R value, which is 10, to the 7th term, our power, wow, divided by 1 minus 10. Okay, so I'm going to get my calculator handy. So for my numerator, I'm going to take 0.4, parentheses, 1 minus 10 to the 7th. I'm going to divide that by 1 minus 10. And we're going to get 444,444.4. So if I add up all these, by the way, that 0.4 at the end is probably this 0.4 at the beginning. That is going to be, oh, forgive me, my phone. So that's why we have a decimal in this. Sometimes it may happen. For the next one, find the sum of the geometric series that's defined by, this is that sigma notation. So we need to figure out A1. So that's just me plugging in 1 to my equation. So 5 times 2, that's 10. We know n is going to be, we're going from 1 to 6, so that's 6 terms. And our r, well, if I look at this equation, 5 times 2 to the n, it turns out that this 2 is the common ratio. It is the thing that we keep multiplying by over and over again. It has the exponent of n. So r is going to be 2. So to find S sub 6, we're going to take our first term, which is 10, multiply that by 1 minus r to the 6th power over 1 minus r. I'm going to use my calculator to do this. And we get 630. Okay. All right. Any questions so far? Well, I don't know why I'm asking this. This is a video. Let's look at a real life application here. So this one says, suppose you're paid 1 cent on the first day of a job. So that's our starting term, A1. For a job, and that amount was doubled each day. So that means R equals 2. And 30 days, that tells us N. How much will you be paid in total over the 30 days? Okay, so since we know all of our pieces, we're going to do S sub 30 equals our first term, which is 0.01, multiplied by 1 minus 2 to the 30th, divided by 1 minus 2. Use a calculator. And we're going to get a really large number. Looks like we're going to get $10,737,418.23. That's a pretty good deal. I want that job. Okay. All right, so all of these, by the way, are things that we call a finite geometric series. Finite because we have a definite beginning and end, okay? So I should have defined that in the beginning here. So a finite geometric series means that we're going to have a definite beginning and a definite ending. So what about infinite geometric series? Sometimes a sequence can go on forever and ever. To find the sum of a series made up of a geometric sequence, we want to first see if the sums converge to a value. If they do converge to a value, then we can find a sum. If they diverge, they won't. Okay, so we're going to talk about a convergent and divergent geometric series. Okay, to do this, we're going to look at partial sums, and we're going to look to see if we notice a value that they approach. Okay. So looking at this first one, we have 1 plus a half plus a fourth plus an eighth plus a 16th. So I'm going to figure out S1, S2, S3, and then I'll do S4, S5, and we'll see if they're approaching some value. So the sum of our first term is just 1. S2 means the sum of the first two terms. So 1 plus a half, it's going to be 1.5 or 3 halves. Sum of the first three terms. By the way, I'm using a calculator that does fractions. Looks like we get 1 3/4, which would be 7/4. S4, that's just me adding up the first four terms. So I'm going to take my third sum and add 1/8 to that. I get 8/7. And I'm going to take that 8/7, I'm going to add 1/16 to it to get my fifth sum. Only 16/15. Okay. So what we want to do is look and see if we're approaching a value. I'm going to convert all of these fractions to decimals. So 3 halves is 1.5. 7/4 would be 1.75. 8/7 would be about 1.1. Wait a minute, 8/7. That doesn't sound right, does it? Oh, maybe it does. It doesn't sound right. I think I've made a mistake somewhere in my S4 and S5 calculation. So I'm going to go back and recalculate S4 and S5. So S4 is going to be 1 plus a half plus a fourth plus an eighth. So 1 plus 1/2 plus 1/4 plus 1/8. Oh, it was 15/8. I just wrote the wrong improper fraction. Whoops. And 15 divided by 8 is 1.875. All right, for our fifth one, we're going to take our 15/8 and add to that 1/16, which is going to give us 31/16. So 31 divided by 16 is 1.9375. All right, so let's take a look at these values. The sums appear to be getting closer and closer to the number 2. So maybe we might conjecture that S sub infinity, meaning we keep going on forever, is about 2, maybe. When that happens, we would say this converges. Okay? Now, if I look at this next one, 1 plus 2 plus 4 plus 8, if I find the first 4 partial sums, I don't need a calculator for this. First one is 1. Second one is 1 plus 2, which is 3. 3 plus the 4 here makes 7. And then 7 plus 8, that's 15. Clearly, these values just keep getting larger and larger. So what we would say is this diverges. So if we take the sum of the first n terms, it's just going to keep getting larger and larger. It's going to diverge. Okay, so if we notice here, let's take a moment to look at what our R values were in each of these. In this first one, I was taking the previous term and multiplying by a half. So our R was 1/2. For the next one, I was doubling the numbers. So we would say R equals 2. When R was 1/2, where we took half the previous value to get the next value, we converged. When R was 2, it kept growing bigger and bigger, and we said it diverged. Okay? So a theorem for a geometric series is that if you took the sum from 1 to infinity of, this is just the geometric sequence formula, and it equals S, we're going to say it converges. So if we add up all these terms of a geometric sequence and we get some finite value S, S is just a number. If this is true, then we say that the series converges, and that's going to happen when the absolute value of R is less than 1, and the sum will be this. Okay? So let's go ahead and take a look at some examples here. So on this first one, I want to see if the series converges or diverges. So step 1, look at R value. In our case, our R value is -4/5. So absolute value of -4/5 equals 4/5, which is less than 1. So this converges. So what does it converge to? What number? We're going to use this formula. S equals, so A1, I have to figure out my first term. So in our case, even though it says A sub 1, our first term is going to be defined by whatever our index starts us at. So I'm going to plug in 0 here, and I would give -4/5 to 0, which is 1, over 1 minus our R value is -4/5. So that's going to be 1 over 1 plus 4/5. So that's going to be double negative. So 1 plus 4/5, 1 and 4/5, common denominator, 4/4 plus, I'm sorry, not 4/4, 5/5. That gives us 9/5. And 1 divided by 9/5 gives us 5/9. So it converges to the value 5/9. That's going to be the sum. Okay. Let's look at this next one. On this next one, we're going to look at the R value. So R equals, let's see, here we got pi over 2 to the n. That's going to be about 3.14 divided by 2, which is 1.57. The absolute value of 1.57 is greater than 1, so it diverges. Because remember, if it diverges, we can't find a sum, so no sum. Okay? On this next one, we have 2 times 1/5 to the n, r equals 1/5. The absolute value of 1/5 is less than 1. So this will have a sum. So we're going to find our first term, plug in 0 here. So we have 2 times 1/5 to the 0. So that's going to be 2 over 1 minus our r value is 1/5. 1 minus 1/5 is 4/5. So we get 2 times 5 over 4, which is 10/4, or 5/2. So the sum is 5 over 2. Okay? All right, so we will practice this in class, but make sure you come with questions.